fingers. I wanted to start with you today with a very different topic. It's something that maybe it is interesting for you. If it is not interesting for you, you just shut down for the next 5 minutes your brain, and maybe for someone this information might be interesting. Have you ever heard about the Digitalization College? Let me present you then the Digitalization College very briefly, okay? Maybe this is something that you want to achieve during your studies here. So what is the Digitalization College? It's kind of degree that you can get during your bachelor's here, okay? It's an additional degree, that a certificate. It is conducted in Bavaria by 17 different colleges or universities. The objective is to strengthen the digital competences of students. And how do we do this? Well, we try to develop with you your soft skills, your digitalization skills, together with students from other faculties. So we have last year students from the Faculty of Applied Informatics, but also students from the Faculty of Economics, Applied Economics, students from the Faculty of different engineers, and so. There were a lot of different kind of students with different backgrounds. Why is it interesting? Well, first, it is in English, but students are both from Germany and from the German courses or the German bachelors and from the English ones. And it is based on challenge didactic. Have you ever heard about this challenge? So how does it work? So like we talk with companies in the region, and they provide us with different challenges, problems that they have, actual real problems, and they try to develop together with you a solution to these problems. It takes you 2 semesters to get this degree, this additional degree. You will have both block seminars and practical applications in teamwork to solve the case study that you will be working. As I said, so you will have like challenges from politics and business team. Why from politics? Because some of the problems that we are facing here in this region, Bavaria, they are connected to for example, this year we have the topic of mobility. So how to improve mobility and new mobility solutions for rural areas, and also things related to health, topics related to health. So digitalization in the health sector. And in these 2 topics, the interest of the public is also like public institutions. It's also relevant. Last year we have energy, and I was in charge of the final summer school, which found place here in Deggendorf at the end of September. We got like 2 international companies, so multinational companies. One was Siemens Energy, and the other one was like MAN. And we have 7 startups, 3 of them from Latin America, 4 of them from Europe, participating on the challenge. We visit also some research and development centers here in the region, and visit also 2 companies. All of this during 1 week, and at the end, the participants had the opportunity to pitch the solution to a jury. The examination is portfolio, like is regarding like your contribution to the teams and the pitches, the presentations that happen every couple of months. And the ideal goal, what we want to achieve, is to prepare you to develop to work on your own startup, to maybe generate a network of professionals, experts that might be interested in same topics as you. In this case, we are going to be focusing on the area of mobility and health, but it is well, doing networking already at this level, it's already something very nice. Of course, you will have a certificate at the end and everything, so you can put it on your CV and blah, 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 blah. And these are more or less the courses that you are going to have. So the introduction to digitalization topic, team building, sustainability and digitalization, digital knowledge communication, conception. I think that's like the most important part, which is how to face a real problem, how to find out what are the background information that is relevant, what it is not, what are the boundaries, what are the possible solutions that are not possible, and so on. And afterwards, you are going to be jumping into prototyping already in the summer semester. There are many things that you, as future experts on artificial intelligence, can learn from this, especially learn to communicate and work with interdisciplinary teams. So you are going to be thinking in algorithms, in code, and other people are going to be thinking in, I don't know, money, cost, marketing, low stuff, you know, and well, this is what we want to do actually. We want you to face the other side of the coin, let's say. So not the technical one, but the one more related with industry and making something happen. And at the end of the year, so there are two interesting things. We will have a spring school for selected students in Chile. So we will be traveling to Chile, and for 10 students, we will be covering the cost. Actually, we are not going to be covering the cost ourselves, but I was very lucky, and I got financing for the Chamber of Commerce and the Ministerium. They were very happy about this project last year and the year before, so they have provided us with some funding. So we will select 10 students to go to the, at least, to go to the University of Concepción in Chile, which is the second best university in Chile. And also some students of the University of Concepción will going to be joining you in the summer school here in September, which is also going to take place at the last week of September, I think. So just before we start the course this year. These are the modules. As you can see, you will have some seminar teaching, but mostly everything is going to be about exercises, oral exams, or research projects. So it's going to be more like interacting with people than really studying. I don't think that you are going to be really studying, like going to the library or something like this. This is not the idea. Well, I can show you some photos of what we have done. As you can see, so we have been visiting different companies. We have been, this is Fenecon, for example. Here, a company startup from the university with they started something like 10 years ago. It was only one person. Now they are more than 250. It is not anymore a small company. We also went to visit we did some field visits. And the photo that you can see here on this side, this is a photo in Chile, visiting a biomass, well, a technological center focusing on the use of biomass. Here are the people. These are all students from Germany participating in Chile. With the final presentations, we also visited many different places during that week. Some of the students also had found some time to drink some beers, visiting the Pacific Ocean. There was a lot of food, and it was like very nice. Like I was with them there, and we have a nice time. There are many professors participating. Maybe some names ring a bell. For example, we have Markus Barkowski, IoT Lab, Smart Lab, Christina Bauer. She has been, I think, working for IBM or Microsoft for a long time. Thomas Geis is the director of the Startup Campus. Christina Baniek, expert on biomimetics, so bionic. And yes, I mean, I think that's very, very interesting. So what you will have also is, of course, all the facilities of the university at your service. So that includes access to all the labs. And we even have gotten some budget also because the ministry is very interested in that we continue developing for prototyping, embedded system, and so on. So you will also have access to labs like deep learning lab at DEC, and so on. This is more or less the schedule. So of course we are taking into account that you have to go to, I mean, you have to do your exams and so on. So there is nothing planned before exams. So usually try to plan this at the end of the week, and sometimes on Saturdays morning. And everything is happening online. I think that this year it's going to be an hybrid mode. Nevertheless, we always recommend everyone to be in presence, because interacting with people in presence sometimes is very valuable. And well, we have the second round schedule. It's a draft. For the moment, we really don't know how it's going to be looking, but you can expect a seminar, let's say, or one of these seminars once per month, something like this. So you have to invest like maybe one Friday and one Saturday morning to visit the university, go to the courses, doing the prototyping and so on. And then all the work that you can do at home or with your colleagues in your team, you just can manage as you want. We have different challenges. So the first one is very easy, like good for us. Like, how can we improve the mobility between our university locations? As you know, the main buildings of the university are here in Deggendorf, but we also have teaching campuses campuses where we are doing teaching in Rotterdam, in the European campus, and another one in Kam, which is, you go to the mountains and so on. But as I am, for example, working at the Technology Campus Ryan, which is very far away, and for us, the problem is how to improve the mobility. Yeah, so the people can go from one side to the other. So there are many things or many possible solutions. The question is, which one is the one that it is technologically feasible, economically makes sense? It is fine also regarding regulation, and so on. And of course, it is sustainable. We also have the Landshut Verkehrsverband, which is the association of whatever, of traffic in Landshut, which is a city here in the region, not close. If you go to Munich, you have to stop in Landshut or pass by. And they have a lot of buses. And then for them, the question is, how do you manage the flow? So the whole buses. I mean, if you are gonna, for example, modify the tariffs, what would be like a tariff model that would be interesting for everyone? Also taking into account that at some point you might be also doing some kind of substitution of all buses by electrical ones. And here you can think of many things. Like, for example, if I have a PV at home, I'm just thinking loud, but if I have a PV at home, maybe I can sell or give my electricity to the Landshut community, and then I will not have to pay anything for the bus because I'm selling my electricity directly to them. And this would be very easy to do with some kind of blockchain algorithm in which we know exactly who is paying what and how much electricity has been sent from point A to point B or whatever. Do you understand my logic? Like, there are many possible things. We also have health. It is related to also like urban areas. Usually it is not a problem, like you find a doctor everywhere, but if you are looking into areas that are a little bit more rural, you have to always go from one place to the other. So there is a lot of things related to how far away is my next doctor, or if I am an old person, can I access to it? It might be, can we do it digitally? What does it mean also for privacy rights and so on? What can we do? What can we not do? And We also have, and we have for this Gesundheitsregion Plus Passau, incentivization of working in healthcare. So there are many, like House 4.0. As you can see, this house is a prototype of an intelligent home. And it exists, okay? You can visit it. It's in one of our campus. And inside this thing, it is full of sensors, okay? That theoretically should provide you with a better quality of life, especially for older people and people with some kind of physical restriction, let's call it like this. I don't know what would be like politically correctly to say that, but yeah, that's more or less the idea. So if you are interested, and you have previous experience, maybe you have been before in a bachelor, you have done something before which is related to these topics, or maybe you don't have done anything related to these topics, but you still want to participate. I really recommend you to submit your application because you never know. And well, we will at some point we will see all the applications and we will decide. And I will be deciding also. And what I like to see is people who have the attitude and want to do something. Okay, there are some good routes. So, like for example, I don't know, like you want to start a startup, or you already have had some ideas on starting a startup, or whatever. That's it. That's all. I hope that was not too much. Now we can start with the course. Do you have questions?
What is the size of the team? Like how much people should be in one team?
Sorry?
How much people should there be in one team? Size of the team.
The assignment.
I'll type it. I'll type.
Yeah, we will talk about that later, just topic by topic. So for this, I will talk about this later. So regarding, do you have questions regarding to? Yes, I think it's the end of this month or the middle of November. Now, regarding the assignment, you can have groups of up to 6 people. I think that I already told you this. 6. Up to 6 means one person should not be enough. I mean, it's not enough. Okay, you have to work together with someone. I want to see at least teams of 3, because if not, we are going to have here 150 presentations, and this is not what I want to see. Okay, so up to 6. And what we can do now together is to find out how many groups do we have. And people who already doesn't have a group, they can join one group. Okay. So I don't know what would be like the best thing. I'm gonna go for the Etherpad. Okay. So 15 minutes per group. Maximum number of students per group is going to be 6, and minimum number 3. Yes. About the topic that it is about on the book. I really would like to see about the content of the book and its relevance or its relationship with ethics in AI. So the module, it's called Ethics in AI. And all the books are about ethics in AI. So what are the dimensions? What are the aspects? What are the giveaways? What are the important ideas? It's 15 minutes. Presentations will take 15 minutes. And you can already like go to the Etherpad and start writing your names and the name of the book, in the case that you already have chosen one. If you don't have a group, just add your name to a book that you would like to read and make. And let's do the following.
Excuse me, can I ask one question? Hello, can you hear me? Hello, can you hear me?
Yes, I can hear you.
I had a problem with my internet and I couldn't hear you before. Can you please explain me again about this presentation and these group meetings?
So we have a module called Ethics in AI. And in the module Ethics in AI, instead of me explaining you things about ethics in AI, I want you to read a book. And I want you to choose one of the books that we had already presented on the first day, or you can choose other book in the case that you think that there is a better book or a book that it is more interesting. And I want you to read the book and provide a presentation to your colleagues about the contents of the book and how it is related, what is important, what are the main ideas that are being discussed, okay, about on that book, about the topic of ethics in AI. So
I understand.
if in order to find a group, you can use the chat. There is a chat here. And then you can threaten, you can use it. And then just say, hi. Photos. You can just discuss it here, okay? So, and once you have discussed
Can I
it,
ask one more question?
yes.
What is the deadline of this presentation and when it will be going to take place?
What is what?
The
deadline. Yeah.
deadline.
The deadline, we are going to set it yet together now. And we are at the end of October. So I think it would be good if we can get this presentation at the end of November.
Can you hear me? What about those who are not present? Can we do it online?
What about what?
Can people that are not in Germany yet?
I think that you mean, what about the students that are online? Yes?
Yeah, yes. People that are online.
Okay. You can also present online.
Okay.
You can share your screen with us and we'll have a look at it.
Okay. Do we have to make groups with people that are online too, or people that are online can be groups with people that are on campus?
I don't understand the question.
Do people who are online have to be groups with themselves, or we can mix it with each other?
You can do however you want. I mean, I only need a presentation and the group can be of people online and offline. You can mix. It is up to you.
Okay, thank you.
No problem. But I'm gonna ask you, and then let's add here something. The deadline for the groups is next week. I want to have the groups next week. So we can schedule who is going to be presenting first, second, third, fourth, and what is going to be the format. Is that fine for everyone?
No, it is not fine for me. Can you please delay the deadline because I will be coming to Dagendorf and I will be traveling from Turkey. So please, can you delay it a little bit more?
You are not happy. You are not conformed.
Can you hear me?
Yes.
I am saying that can you delay it a little bit more because I will be traveling from Turkey to Dagendorf.
No, I'm sorry. It's gonna be in this week. You need to have the groups built, okay? And the presentations are gonna be on the 28th. Is it clear for everyone? I mean, some of you have already read some of the books probably because they are like bestsellers. So enjoy, like you don't enjoy reading another book if you want to, or just read. I mean, you can do the presentation on the book that you have already written. So I don't want you to prepare 25 slides for a presentation of 15 minutes. So no need to. I just want you to explain the others, what you have learned, if you have learned anything, and you can critique. It can be what I don't want to do, and this is why I'm doing this way. I don't want to impose anyone anything. You are free to think whatever you want. I have my personal point of view about ethics in IA, and yeah, I'm biased. And every time that I face this with students, there's a lot of discussions, and I love these discussions, but I don't think that we have enough time to engage in that discussions. So I think that if you read a book by yourself and you discuss in a group, And then we have these presentations, you will have different point of views from different colleagues, and this will lead to maybe some discussions after the course, during drinking a coffee or having lunch together. And this is what I want to foster at the same time that you're learning something. Okay? Other questions? Are there any questions? How is it going with the other parts? Okay, now we have two groups with the same book. It's not a problem, okay? But please, for so that everyone I mean, let's make this funny and interesting for everyone. So try to choose different books, okay? And not always the same book and the same book, like the smallest one with the less number of pages or whatever. Just try to, at the end, each one of you are going to be reading what, one chapter, two chapters? Yeah, it's not that bad. So do you want to continue with the course? Okay, then. For today, we have a chapter about mathematical logic. I think I have made some mistakes on the titles, but okay, it doesn't matter. And there is a nice book that you can find online if you Google it, which is called Artificial Intelligence, a Modern Approach, third edition. Can you have a look at it? If you can find it, if you can Google it. Artificial Intelligence, a Modern Approach, third edition. It should be online on PDF. I have found it at the UCLA. I will share with you my slides at the end, so you can also have the link, but I just want to see if you can find it now, like just for Googling. Just Google Artificial Intelligence, a Modern Approach, third edition PDF. It is this one. Right? Yeah, okay. So it's a very nice book. We are not going to be using it all the time. So today we are only interested in sections number 7.1 to section number 7.5. And also we are going to be looking into section number 8. So everything that I'm going to be telling you today, it is related to that book. Okay. So what we saw yesterday is that a proposition is a kind of statement that can be checked in the real world somehow. This is the definition that we were using. You have a proposition, and this proposition can be true, or this proposition can be false. They only have these two possible values, and they have to have one of these values. It is not possible that a proposition doesn't have a value. It is also not possible that a proposition has a true and a false value at the same time. Do we agree? Yes. So if I say in 1492, Columbus sailed the ocean blue, it is true. Napoleon won the Battle of Waterloo. No, he didn't. One is true and the other one is false. So we can also think propositional logic as sentences represent proposition. We can also say that a sentence can refer to another sentence, and propositions can also be think as PQR, which are the names that we just provide to them. Okay, P is a kind of proposition, Q is also called a proposition, and R is also a proposition. There is something that I explained last time that I'm not sure if it was clear. So this is why we are going to be doing the recap and some exercises on it. Let's see. I hope that you can see me, the one that is the people that are online. Is my camera on and you can see me?
No,
I'm
sir.
asking. No?
No.
Because if not, this is going to be difficult. Okay. Can you see me now?
Yes, we can see you now.
I'm going to try to write here something, okay? And let's see, hopefully you can see it. So a proposition can be true or can be false. And we can say that there is some kind of symbols that will allow us to define if something is true or if it is not true, and the connections between different propositions. For example, we have this symbol here. Can you see this? Yes. Which is the symbol not. If I say not true, this is going to be equal to false. Okay. So based on this, what I can do is generate a kind of truth table. Yes? A truth table. So I can have a proposition Q and a proposition P. And I can start playing with them by using the different connectors. So
Sir, the whiteboard is not clear.
Okay, so I will try everything that I'm explaining. It is also on the book chapter. So if you cannot see what I'm writing, I recommend you to look into the book chapter. I cannot change now the video settings. Sorry. You think this one is giving me? What are all the possible combinations of Q and P? Okay, thank you. So it can be true, 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 false, false, true, false, and false. And if I say Q and P, it's gonna be why? Because okay, so either true, Q is true, or either P is true, so it is true. What about true and false? What will be here in the outcome? Okay. What? it is at the same time Q and at the same time P. So it is not possible, so it is false. It's false and true. It's gonna be and F and F. For those that are thinking in true, what is the logic behind it?
Then both must be for something to happen, for example.
Okay, so this is a normal question of power. Okay, so if we have Q and we have P, then something happens. And if we don't have Q and we don't have P, nothing is going to happen. And this is for the people assuming that the result is false. And for the people assuming that the result is true, what is the logic behind it? Who said true? Don't be afraid because you have made no mistake. There is no mistake. We are in a classroom. Some have mistake. Classroom have no mistake. So false and false, and we get a true. How is it possible? Don't use ChatGPT. What do you think? What? Nothing? No ideas? Okay, so this truth table is this like the common agreement for all the course from all of you? Okay. Now we can set in propositional logic, okay, truth tables, okay, based on the different values of a proposition. Yes. So we will determine. We will try to find out what are all the possible combinations that exist so that we can have a knowledge base. Okay, knowledge base is a base of knowledge of all the possible situations. Yeah. In this case, we have two possible values for P. P is false, or P is true. Not P is true when it is false, right? Let's look at and. False, false is false. False, true is false. True and false is false. True and true is. How can I help you doing this exercise and not making the mistake of the true statement 2 times? This is a very good idea on thinking on causality, but also you can think in what Aristotle called as subgroups and groups. Yes? Because Aristotle was not really like thinking in causality, it was thinking on group. Okay? Do you remember last lecture? So if something is P, if something is Q, and something is let's say, if something is part of the group Q, and something is part of the group P, it is part of the group Q, and it is also part of the group P. If something it is part of the group P, but it is not part of the group P, it cannot be part of the group P and Q. So who wants to draw then diagram of I mean, I will recommend you to do it now. This is before you start. So, try to do it by yourself. Don't do it diagram. Only for big one. Right? First, very important.
Hello, can you hear me? Hello.
Yes, we have a colleague, and this is the exercise. Try
We-
to try to draw a Venn diagram of the AND proposition. Okay, no problem. So, do you have the same result? Do we write G and F inside the diagram? So, actually, I mean, this is okay, more or less. Actually, what we want to say is this is the group Q. Okay, this is Q. And here, what we have is P. You can put it also inside if you want. Okay, this is Q and this is P. Right? Right? Now, what we have is Q and P, right? And this is what you correctly did also, right? And you have Q and P. And Q and P is inside. Stuff that is Q and P at the same time. A proposition that you give yesterday as an example, it was you. Some of the students in this course have a computer. Do have a computer. So we have computers and students. And some of the students have a computer, right? So true is which area? This here, yeah? True false is which area? This one, right? Now we have this area and false false. We usually do like this. So my recommendation for you is that this course, this introduction to logic, it's very easy. Everyone can follow, but everyone can make mistakes. So do the exercises, okay? Please do the exercises at home, because if not, I will put you in a situation with the test that you will not want to be, like you make a mistake, okay? Let's look into OR, okay? What will be OR? Q or P? First one? Louder. Second one? This one? Okay, amen. Okay, now we are speaking. Now we are talking. This is area, and it is very easy. Why with OR? It is very easy because the rule is if you have one that meets it's true, then the final it is going to be true. Yeah, like the disjunction is going to be true. Disjunction. I'm talking now, yeah, about terms. Please remember disjunction. Maybe instead of writing or in the exam, I'm telling you what is the disjunction, what is the true table, the correct true table of this disjunction. So you have to understand the terms you are talking and you are working with. Clear, okay? What about the implication? This is more with causality. What would be like the first one? True and true. How about the causality in groups? Yes. Yeah, but in groups, like you remember, I think that it is part of the group. An example? Yeah, not that easy. Okay, it's fine. So want to take one of mine? Now, I hope that you can at least listen to me. Next week will be better. So if we have false, or we have true and false, what will be then the result? Why? Can you explain? Okay, then I really recommend you, okay, because we said this last week, I really recommend you to look into the chapter 7.1, 7.2, 7.3, and 7.4. Everything is explained in the book, okay? It's more or less what we have seen last week, and you also have the exercises, yes, from the introduction, all the slides. Did you have time to look into them? Some of you, not many people. So is the quantity of exercises that I am providing to you overwhelming, or should I reduce? Should I give you more? Just feedback for me. It's fine. It's fine. So if both are false, it is going to be true. If P is false, then Q is going to be true. If Q is true, then the implication of Q is false, it's going to be false, and true is true. And you have the conditional, another two table, okay, in which you have much easier. What does it mean, be conditional? By condition. Okay. Okay. And this is on the last one. But I think that we want to probably very fast to be too far. Okay.
The conditional implies that the
From the conditional. Yes, it should be both. It should be at the same time, exactly the same. So it doesn't matter if you're looking to the right side or the left side, both should be the same. Only if. Yeah, so that leads us to the next exercise. And I want you to do the exercises because I'm not sure if you are doing the exercises at home. So I have exercises for you. I want you to construct a truth table for the following logical expression. The truth tables with the solutions are on the PDF file slide of that week. Would you two try to solve these exercises, please? So how do we start solving this problem? What I recommend you is to start by looking at all the possible combinations. Yes? And now what we can say is, let's look into the parentheses, yes? First. Solving the parentheses is relatively easy because you only have to look at the AND table. Yes? And then substitute. What do we have? Not B, right? Not B. Or it's not Q. Not B, right? Not B. Whatever. Fine. Not B. Or is B here? True. Then not B will be. And now what we have is or. Another proposition. There's new variables. So, what is like not or what is or? Okay. Have you solved the first one and the second one? Okay, then. For those already on the third one, if I have Q, what is Q? A proposition, right? I can have P, which is another proposition, and I can have R, which is another proposition. What is the number of combinations that we have? Okay. So, 2, 4, 6, 4, 2, 4, 2. Four, 4, 2, 4, 4, and continue until you have all of them. And then you have to check if the right side is exactly the same as the like the problem into sub-problems. So this is for the ones, for the third one, there are 3 propositions. So the 3 propositions are Q, P, R. And then now the truth, it is bigger. So the truth table, it is getting more complicated because there are more combinations. Who wants to solve the first one? It's almost solved. You only need to do the OR. Yes, sure. Oh, now the problem. Everyone agrees? Does everyone agree? Or do you have another result? Yes. Do you agree? Okay, thank you. Anyone else? No one. Yes. This one. This one follow after the other because actually, if you want, you can write this like this. Okay? It is not P. And not P is here. Yeah, so the exercise is actually to find out this proposition. Can you try to translate this in words? P and Q or not P. This is the same as here, but with the parentheses here, you can read that, okay? But you don't need it. Because this not is applying to the next one. So at the end, what you have is like 2 specific problems. The one which is, let's say, the 2 propositions inside the parentheses, and then the not P, which is also very easy. And then now you can just continue. It's like when you were doing maths when you were at school. Who wants to solve the next one? Someone? Can someone solve the next one? Please. Yes, please. I'm just clearing everything. So how do you start? Like, can you explain your colleagues what is that how do you organize?
Yeah, start with like all this situation where there are two variables, B and Q. So I start with like typing B and Q. What are the possibilities? There are like four possibilities. Like those are the possibilities, and then I start like with the first B, and there's like Q and B, and there is and the final part. Okay, so like we need to like this is the first part and this is the second one. Okay. So like
This is the implication, yes?
Yeah.
We have Q.
So like it's the problem for me like I did B first. So
Then try to find out that. Have TT. TT can do that. And then just have
like the previous one.
Does everyone agree? No, someone doesn't. Yes? It should be false here and true here. All of them are false. There is only one true. Have another person that disagrees with the other one? What? No problem. It is completely fine. We agree that we disagree. So, what is the logical way to think of? Okay, if I have two values, the set are Q and P at the same time. Yes, and then P being true implies that Q and P.
Hello,
should
can
be
you hear
true.
me? Hello. The camera is on the other side. Can you please shift the camera to the blackboard, to the board?
Yeah.
We don't
Now.
see anything really.
Maybe you can make my picture bigger. I think that you can do that in Zoom. You just look at my picture and my
Okay.
video instead. Sorry. Okay. Do we agree on the first one? Everyone agree on the first one? So if P is true, then it implies that Q and P is also true and they are actually true. Okay.
This is called this so both before so this condition is not true because both of them are false. First, the B is false and not that Q and B are false. So this is true.
P is false. Therefore, if P, Q, and P has to be false.
This was true, like not false. This will be false. But because both of them is false, this is false, this is false. So this is true actually.
Yeah or not?
It depends on the first one.
In the first one, Q and P, but P is always here.
Yeah.
Okay, now we have P being true, but Q and P is false. How is that possible? Is it possible that something, now listen to me. Is it possible that something that is P It is not P and Q. Why? Okay. Now, when you close your eyes, you should be able to see this thing. And we have P. Is it possible that something that is P, it is not P and Q? I have something that is P, but it is not P and Q. Do you understand the logic? No. Okay. So, is it possible that you are a student? Yes. The Faculty of Applied Economics? Yes. It is possible. But I know that you are not, because it is false. So I know that you are not here. It is false. Okay? Okay. Good. Thank you. There are. I will give you the result for the last one because it's very long.
I have one question.
Yes.
Have you uploaded these slides on iLearn? These
No, I
slides,
will
the
upload
one
them
that you are
today.
just teaching.
I will upload
If
them
you can
today.
if you can upload these slides before the class so that we can study a little bit, then it will be easier for us.
Okay, I will do it when I have the time, when there is the break. Okay, we are gonna do a break.
Okay,
and
thank
then I
you.
will upload
Thank
the
you so
slides.
much. Thank you so much.
Is it is 15? Okay. Let's look into the next idea. So, an expression, and this is going to be very interesting for you. For example, when you are going to be, when you are going to be looking into random forest, for example, or decision trees, and is that an expression involving logical variables that is true for all values is called a tautology. It is something that it is always true. Doesn't matter what you say. And the second proposition, that's a tautology. Yes, it is always true. On the other hand, an expression involving logical variables that is false for all values is called a contradiction. And this is an example of the first or of the second. Can you try to solve this one? So not P. Sorry? If you can what? No. We do this and then we go to the break, okay? Q or P. Q or Okay. Oh, I'm just printing. It's correct. I can't make mistakes. I'm just doing the exercise at the same time that you are doing it. And it's not like I do this every day in the morning. Looks good, I think. So then we have, you know why I know that this is an or statement? Because in the statement, you can do like this. I always make mistakes with symbols, yeah? I didn't know that we have R. Ah, sorry. Then we need to modify this. True, false, false. True, false, false. Yeah. Okay, Simon says this. That's it, isn't it? Now I can continue. You, oh, R. False. Am I right? Now for the final one. Not B. Yes. Problem. This one? Oh. False, false, false. False. Yes? Not you are. Look at this one. F. True. F. True. Is it right? Okay, not B. Now? And now what is this? A tautology? It's a tautology. A tautology is what? Organism always true. If it is not P, it cannot be Q or R. If it is not Q or R, what is it? P or not? If it is not P, it is both. It is false. It is not P. It is false. False. It is not Q and R. Have to check. I think it's true.
Sir,
Yes.
can you show the answer? Can you show the whiteboard so we can compare our answers?
Yes, I will give you the solution. So let's make a break. Let me look into this. Let's see my mistakes. And we'll be back in 10 minutes. Okay. So let's go back to the exercise. I think that I have seen what my mistake was or is actually, and my mistake is that I was thinking that I was providing you a tautology, and I was fixed with the tautology. Actually, it is not. So it is not a tautology, and it is also not a contradiction. So what is the next value? So we have not P implies not Q or R. And you have a now we have not P and not Q or Q. Why? No, yeah, okay. If I ask something and you can just say what. These rules, so that's the implies like not Q or R. Then we have a not P implies that it is not Q or R. Which one is? False while we have truth and false. Okay. We have something I think is not P. Something that it is also false. It is false and it is false, it should be true. It is false and it is false again. We have another truth. Yes? We have another 2. And here we are just repeating the same as we have seen before. T, yes. We have tried that next. And we are just seeing one more time the same thing again and again and again. Well, I was thinking that I had a tautology example. I will upload a tautology example for you, okay? So that you can see a tautology. In the exam, you are not going to see these complicated exercises because you have 100 questions. For me, and it's not something like that. So you will have examples, each example. The idea is just that you follow follow the logic for each examples, and I will show you now how to translate this into an algorithm, a real algorithm. So I already provided you with this example yesterday, right? With this example, we understood that with Boole and Shannon, it is possible based on this logic, you can start constructing the logic behind electrical circuits. Can you imagine of an additional application, something that might be interesting related to this logic? Some kind of artificial intelligence application, something. No? Let me provide you with this example, the Wumpus world. Do you know the Wumpus world? It's a very nice exercise. An exercise, it is in the book. Okay? It is explained there. I'm going to try to play with you the Wumpus world. And let's see if everyone understands the logic behind it. And then probably you will know if you have a vacuum that goes everywhere and try to clean your house, you will see that they are based on this, on the Wumpus world. Some of them, not all of them, but some of them. So what is a Wumpus world? Let's say the idea is that we have we're going to have an agent, okay? What is an agent? An agent is a kind of system that is able to make decisions based on a set of rules. Yes? A set of rules and a set of possible actions, right? So in this case, we are going to have the knight here, the archer, and the archer we can define as A in this one. And A, the archer, has a kind of objective during the game. The objective of the archer is to find the goal and escape the cave, the labyrinth, okay, the map, alive. Do you understand? So in order to do this, it is explained again on the book. What you can do is a utility function in which, for example, dying, so you want to achieve the maximum number of points as possible, getting the goal gives you from 1 to 10 to 10,000 points. Dying will give you 0 points. The archer can use an arrow to kill the Wumpus, okay? For using it, it will be losing 10 points. And every time that the archer is making a movement, it will have a -1 point. Do you understand? So this is just like you define the criteria to maximize, okay, an utility function. And this is how we do it. Questions? No question. Now, the point is, what is the set of actions that you can do, and what is the knowledge base that the archer has? The archer knows that it has an arrow, right? And if it is using it, it is going to be losing 10 points. He knows also that every move costs 1 point, right? And he doesn't want to die. What are different forms of dying that we can find? One is getting into a pit, right? You get into a pit. These are the pits here, which are holes on the ground that send you to a different space and time, and you will never be back, and then you are dead, for example. Okay? You have the pit. And now we have the Wumpus that is actual, only actual. And if you go to the place where the Wumpus is, then the actor is going to be there. So the Wumpus and the pits represent the positions in which the archer, if he moves to these positions, will be there. Do you understand? Everything is understandable. Okay, now there is something interesting about the pits, and is that if you are close to a pit, then the archer is gonna feel a breeze. Yeah, do you know what a breeze is? It's a kind of wind. They're like, okay, there's something here, but the breeze only appears in positions that are directly on the laterals or up and down, okay, directly the next position in the grid. Yes? So if we have a pit here, you will find a breeze only on this. Yes? On the other hand, the Wumpus didn't took a shower in the last 3 years, and it's a little bit smelly. So you will find this stench, okay, close to it. Now, the archer can only move right or left and advance. How do we solve this? In this manner. This is logic, because you have a set of rules, and then you have to behave based on the knowledge that you have. The archer we should provide the archer with a specific set of action or logical action that allows him to avoid the Wumpus and avoid the pit. Now we can see everything. Yes? We are both, and we see the world from above, and we see the Wumpus, the pit, and the archer. But let's look into the archer. What can the archer see? And something very important. The archers know that the 1-1, the entry area of a cave, let's imagine a cave, it is always safe. Right? It is always safe. So what can he see? So you will have 1-1, 2, 3, 4. 1, 2, 3, and 4. Right?
Can I ask one thing?
Yes, you cannot see. Sorry.
Yes, we cannot see. If you can teach on the left side, it would be better. If you can teach on the left side, yeah,
Okay.
this side. Yes, it is. It is more suitable.
We'll try. So we have a bridge. And what is the archer looking at? The archer is here. He cannot advance in diagonal. What is the information that he has? He has no information, right? So what are the possible movements that the archer has? Up or right? Okay. And he knows that this one is for free and this one is for free. Why? No breeze and okay. So where do you want to go? You want to go up? Right? Right or up? Come on. Raise your hand if you want to go up. Okay. So then I think that you are going to go right. Now, this is an interval T. Yeah. In T, I know this about this word. Now we are going to go to the next time interval. Now we are here. What can we feel? What happens? Breeze. Okay. What does it mean? Huh? There is a pit nearby. It is above or it's in the right. Okay, right. And you can move in all the directions. You just have to move right or left. Right? You understand? So you just use like, if I want to go, I am the archer. If I want to go in this direction, I will have to move like this. I will go this direction. I want to go back. I have to move forward, then one, and I have to go. Right? So now we have three here, okay? A and breeze. What does it mean? What are the possibilities? Actually, we have more. Yes, okay. We have a bit here. Or we have a bit here. Everyone agree? Okay. But what else does the archer know? He knows more things. He knows that this, and this is the interesting idea, is that there are different possibilities. The first possibility will be we have a pit, and a pit. Here, for example. Yeah, and this is 2, this is 1, and this is 1. 2 and is this possible? No. Why? But still is a possibility. It's a false statement. But it's a possibility. I mean, we can consider it based on the rules. We can say this is not possible because it contradicts the rules, but still, this is a possible combination, right? Now the next one will be, and we say like, okay, this one cannot be. We agree. I mean, I completely agree with you. This is not possible because then I will feel a bit here. So then what will be the next one? Like maybe this one? Not possible. Based on the rules. This one can be possible. Possible. Still possible. So what do you do? You go out, yeah, you know. But he's very conservative because he knows that if he loses, if you go to the page, you are losing 0, and you are getting 0. So it is always the from the point of view of the archer, and the archer is a very safe person. He never makes any mistake, tries at least. He will try to go back, right? Because he knows that this is too risky at this moment. So he will be back. Now I know that this is a risk. I'm going to be back. What do you do? What do you do next? Go.
And what do you get? Exactly. But the monster is maybe here. Why not? Exactly. So you see, you're using Aristotelian logic. What did we talk last week? True and false are the same. You see, Aristotelian logic is embedded in everything that we do. So, this is here. Rumpus, right? Now you know this is free. So what do you do? And what do you feel now?
Sir, can you hear me?
Yes, I can hear you.
Sir, we literally cannot understand what's been going in the class since last 1 hour.
Yeah, we are trying to solve the problem of the Wumpus.
Sir, can you make that camera clear or something? Like we online
Yes,
students
you can
cannot
read-
understand anything.
You can read section 7.3 of the book, and you will have a very similar explanation. I'm just following the book.
Also,
you
you
are-
didn't share the slides. You didn't share the slides this time. Since you come after the break, you didn't share the
Yeah.
slides.
No, I didn't change anything. The slides are up. Isn't it? It's the number 13.
Okay.
So now we have, now that we are here, now the question is, what do you want to go? I mean, if you don't look up, okay, you can go here, right? If you go here, what is the knowledge that you are adding to your knowledge base of this, which means it might be here, it might be here, possible fits, yes? So what do you wanna go? Go back. You feel nothing. What do you wanna go? Cold. Now you feel the cold, you get the cold, and you go back. So when people buy a vacuum cleaner, the vacuum cleaner is sometimes following this logic. I move in this direction until I find a kind of problem. Sometimes they have these things like they have some kind of sensor that they are providing them with information on. There is something in front of you that might be dangerous. You don't want to enter there. Just go back and move and continue. It's so easy, but it works. Yeah. Of course, you can buy one with a camera and can generate a 3D model of your room and your apartment. But this thing is still working. Yes. So this is knowledge representation, okay, and can be used for many different things. Many different things. Can you give me another example? Yes. For example,
Well, one time we also had some things about we were how I think we were the mouse and they were fighting like they were trying to the mouse were trying to get the cheap as possible. And there was just always just one movement at a time. And then they were giving the cheap or movement different grades of what they are. And according to that, then the mouse were learning where to move best to get the highest value.
the utility value or whatever yeah, exactly the same. So same logic. So now that let's go back to this idea Okay, we can define a proposition as a sentence that define. So a proposition is in propositional logic is a sentence that represent propositions. We can also think on quantifiers, which are also very related to math. Okay, and this is the last idea I want to share with you today. So the phrase for every x, so for all x, is called a universal quantifier, and you can also have a existential quantifier. What is the difference between both of them? At least one. There is one solution for this problem, yes, that might meet a specific number of requirements. And this is optimization algorithms all the time, yes? So we call them here quantifiers, and they can be universal or existential. I have an example from my colleague who was teaching this last year. I think that it's a little bit confusing, but maybe it is not for you. He's a computer scientist, and I think that computer scientists you like this kind of things. Let's see if I can find it. Yeah, here, like no, I'm just gonna do it here. Oh well, maybe I can share the screens. Yeah. This is an exercise from last year. I don't know if you're gonna be finding it interesting. Let's see. Can you see this slide? The people online. The example with the semantics. Yeah, I think they can. So let's say that we have three different constants. Okay, C1, C2, and C3. No, they cannot see it. I'm not screen sharing.
Sir, can you share your screen? Yeah.
So C1, C2, and C3. And we have two-place function symbol plus, which is going to be sum. And then we have two-place predicate symbol gr, which might be greater than greater. Yes? So we have a formula, and the formula is greater than C2, C1, C3, C2. Is this an absolute or a? Well, it is an absolute or it is not. What do you think? How can you find out this? You can substitute, isn't it? By a number of by given numbers. So let's say that we substitute C1 by 1, C3 by 3, and C2 by 2. What is the solution of this? This, isn't it? Like you have F equal to rate plus C1, C3, and C2. And what do we have now? This is equal to say plus C1 and C3 greater than 2. Right? Let's see if the colleague wants to say something. Choose interpretation. C1 is going to be C1 equal to 1, C2 is going to be 2, C3 is going to be 3, plus is going to be plus, and rate 1 to 3 is bigger than 2, which is equal to 4, bigger than 2. Same thing. if we have the numbers 1, 2, 3, 4, does it apply for all of them? All the combinations? Not, isn't it? Then it's an existential quantifier. Okay, it doesn't matter. Let's go back. Just wanted to show you like how can also you look at the same thing in different ways. Now, a formula, then at the end, numbers, okay? And formulas can also be thought and can be understood in the same way, which is something that we have seen before. And this is connected to what? So, FTSE logic. And this is my point of today, let's say. So a formula can be understood as a statement whose true value may depend on the values of some variables. And this thing, the problem that we have with this kind of algebra is that it is either true or false. There are no possibilities in between. And what we want to jump is into something new. We want to jump into the world of probabilities. So how do we do this? How do you think that we can do this? To jump from the world of true or false things that are either true or false, to things that are maybe one thing or the other. The first thing that we need to understand.
Experiments.
Experiments, yeah, okay. Experiments are possible. If we are looking at experiments, we might find something like this. Let's say that I asked all the people here with blue eyes how old they are at the university, and I get something like this. Yes, a distribution following a normal distribution, a t-student distribution with an average of 22. Yes, and it's completely fine. And now I am asking the same question to people with brown eyes, and they are giving me this distribution with a mean of 90. If I'm taking an individual here, one person here, X, I, or E, I, whatever, like whoever they are, how do I know that they are part of one distribution or the other? There should be a probability assigned to it, isn't it? There should be some kind of way to define. This might be the case, but I am not sure. And actually, you can somehow define what is the probability of something happening, yeah, based on that. So based on the distributions. So in what we are gonna see next week is how can we start thinking on concepts that you have been probably studying at home during the last month before starting this course. If you have a deep learning algorithm and you have a node.
Can you hear me?
The main idea, yes, is that you're gonna have here something like this. A function, right? What is the name of these functions? Activation, yeah, they activate. There are some neurons inside a network, nodes, and they have an activation function. Okay, how do they get active?
When they pass a certain threshold.
Threshold. Okay, now we have a threshold, which means that I can, and this is the main idea behind FATSI algorithm, is that let's say that everything that is 17 or more. These are all students. If they are 17 or more, yes, they are all students in the university. But we can also say that I will not find students can have also this form with more than 40 years. I haven't seen students with more than 40 years. So all the students, they are going to be between these two values. So at some point, an activation function can tell me, okay, pass out, look, I am activated. I know that it is not a student, and I can, and this one might be looking into something else, might be looking into, it is regarding the age, it is not a student, regarding the color of the eyes, it is student in artificial intelligence or student in the faculty of whatever. The next one might be providing me with other information. So I'm creating sets and subsets and subsets. And at the end, I'm going to find out, okay, the first neuron is telling me if it's part of this group or it has a possibility, probability. I activate already my set. I'm telling you, okay, this might be the case. Even if I'm not completely sure. Yeah, even if I'm not completely sure, I do think that I have a probability assigned to this feature of a specific individual. And it continues like this. So how does it work? So yes, you use the logic that we have seen until now. At some point, these neurons, they might be a specific set of logic. Yes, but the activation functions, they might be using another kind of logic inside them. So you can play with different sets of logic. So FODC algorithms and FODC sets, yes, are sets in which an individual can be true and false at the same time. Now, yes. And this is making the exercises that we are going to do more difficult, but also more interesting. Because now we are going to see into things that we don't know what they exactly are. Do you know recommendation systems? Have you ever heard about recommendation systems?
Like movie recommendation systems?
Recommendation systems, yes. Like Netflix? Do you have Netflix or Amazon Prime or something like this? How does it know what do you want to look at? How does it work?
Basically, it figures out the pattern on what we are watching.
No. Yes and no. Is that they are always facing the problem of having lack of data. Yes, because you're not watching enough Netflix. So let's say you have an individual one and you have different things. And have you watched Batman and Robin? And maybe you are looking into sex education. And then you have another thing from Netflix, I don't know, like Black Mirror. And then you have, can you tell me a drama? Or a comedy? What was one? Come on, one drama.
The Witcher.
Drama.
Witcher.
Witcher. This is not a drama. Okay, let's keep the Witcher and James Bond. Okay, come on. So the first user has been looking into this thing and he lost. Okay. And he has also been watching Batman and Robin and of course James Bond stuff. The second user has been looking more into Black Mirror and The Witcher. And the third user has been only looking into sex education and Batman and Robin. So what would you recommend next? Yes? What do you recommend next to I3? Why? They're in interest. You don't know if, looking into what we have seen before, if we are all and all these things, how does it work? But you can set a system based on it and assign a probability. And saying that, I mean, I don't know if you are into James Bond stuff, but let's call it R. But I know that you have Q and you have P. And I know that Qs like R. So you should be looking into this thing. And this is how it works. Easy algorithms. Of course, you can complicate it more and more. I was preparing this lecture, because believe it or not, I prepared them. I was reading an interesting paper about an algorithm. It was this is just my last idea that I want to share with you. Okay, I will upload the paper if you want to look at. You know what a paper is?
Yes.
It was very interesting because it was published, I think, in what was AI and Society or something like this, or Ethics and AI. I don't remember the journal, but it was a good journal. And they did an experiment. So the experiment was the following. In Netherlands, if you want to apply for a visa to enter the country, to stay in the country and live in the country, and you are a foreigner, they are going to look into a specific set of things, like, have you provided this document? Have you provided the other document? Do you have this and the other thing? And based on this and the other thing, yeah, they are going to recommend you, and they have an algorithm to recommend if they should accept or not an application. Yeah, it works, and they are using it. So they were thinking like, okay, the algorithm is providing the person making a decision with a preference, let's say, on accepting or rejecting the visa. And they were thinking like, what about, and the algorithm was based on logic, yes, and groups and subgroups, like very easy algorithm, like a tree. We're going to see, if you are interested, let's see next week. Don't forget this. We are going to look already onto real algorithms that are based on everything that we have seen during these 2 days. Like, for example, a decision tree. So the decision tree works like this, like yes or no. So do you have an application? Do you have all the requirements documents? Yes. Don't? No. And you divide them into 2, always into 2. Yes? Good. These algorithms have been used for 5 years, and there are experts looking into these things, getting the input from the algorithms and making decisions. Sometimes they make right decisions, and sometimes they make mistakes. They are humans. It's completely normal. And what they were doing, and they were trying, is, why don't we develop a better algorithm based on probability and deep learning and stuff, like complicated stuff, that performs better, that provides better recommendations to the experts. What do you think that happened?
What's the question, sir?
What do you think that happened when the experts were facing the recommendation of the 2 algorithms? Yes, the algorithm based on logical sets and easy rules, something that they could understand. And when the algorithms were a little bit more difficult,
Yeah,
but the results
they went for neural networks. That's why we saw such explosion of neural networks and deep learning models.
Okay, yes, but what do you think was the reaction, like the performance? of the final of the expert.
It was good, obviously, that's why that was adopted.
Okay. No idea? Like, you don't want to say anything? You don't want to make a mistake? I'm making mistakes all the time, come on. So it was very difficult for them to follow the logic behind why choosing one thing or the other thing. So they couldn't realize the improvements on efficiency of the new algorithm. So for them, it was much easier to follow recommendations from algorithms that they can understand and they are transparent. I think that this is very interesting, and this is why we are looking into this, because of course you can create very complicated stuff, but this stuff at some point it's going to be used by someone. And this someone is going to be making decisions, and this is what recommendation algorithms are about, making decisions, supporting decision makers. Yeah, and the decision maker can be the vacuum, or it can be a person deciding about visa of a person. Yeah. So sometimes you want to go to these simple logics, and sometimes you want to complicate them. Yeah. If you are interested, I can update upload the article. And for next week, I want you to look into Jaccard similarity. Jaccard similarity. Can you do that? Jaccard similarity. And I'm gonna upload one chapter. I want you to look into that. Okay. I'm gonna tell you which section. So this is just your homework. For people that had finished the exercises from last week and want to keep learning, you have problems of first order logic. In which what you are being required is to translate English sentences to first order logic. They are relatively easy and get more complicated through time. You will have exercises, okay, on translating from first order logic to sentences. Can you follow this one? Like, for example, what will be this? All X. Yes, all X. All apples are red. If it is an apple, it implies that it is red. Or red things are apples. What? Red things are apples, or all apples are red? There is an X. All X, and there is an Y, for which, how do you translate this? All? The same one, for example. And is there a question? Because the example is with person. Log means a person X logs a person E. So all persons log one person. It's an all some and all. Go to the exercise and we will discuss them tomorrow. And I will upload, of course, the solution. Okay? I'm gonna repeat. I have uploaded the exercises. I'm gonna ask you to do the exercises. And I will also upload the solutions. Of course. Can I stay here now and do the exercises? You have to be here. So for the people online, I hope that next week I will get this system working. I'm very sorry that it didn't work. One more time. Is there any question, something that I can do for you? Can you write in the chat? Because right now here is a little bit loading. So if you want to write down on the chat some of your questions, I will try to solve them now. Things that are not clear or